Hi everybody. Today we will continue with part 2 of our 8-channel main power relay board switch presentation, the new MPRS version 3.4.1 board that we start talking last time. Um, and I'm thinking it might be a good idea today to um, talk a little bit more about, let's say, a short, quick software example, and after that, if it's necessary, we can come back with more hardware stuff. Uh, it's only one thing that I want to mention because there were a lot of people uh, talking about this and also asking about this thing. Um, so what I want to tell you it's that uh, this board was designed uh, with the safety in mind, and there were a lot of questions related with the power supply and with the fact it's connected to the mains, or it can be connected to the mains. Yeah. So as I said last time, the board, it's split it, if you want, in three big parts. Yeah, we have the power supply part, we have the block relay part, if you want, and we have the command and control part. Yeah. Regarding the power supply, this power supply, it's a fully isolated power supply. So that means that is no connection between the mains input and the output. The ground from here is not connected with the neutral there, yeah, or with the live, yeah. This is a, if you want, it's a floating power supply, yeah? So it's no connection between them. And also it has a proper ceramic fuse, and it's guarded with a proper move. Yeah. Okay. So also between the power supply and the relay block, if you want, again, it's no direct connection. Yeah. So as I said, you can, if you want, imagine this relay block as 8 independent switches, and you can switch with them here from, I don't know, your 1 volt or 3 volts or 5 volts or 12 volts or 24 volts voltage line up to the mains line. Yeah, that means 120 or 240 volt. Yeah. Okay. The total power, it's 10 amps. Yeah, so basically you can switch 10 amps with this board. Yeah. Okay. Now regarding again about the power supplies, yeah, and how it's done, we have the mains power supply here. It will give us out the proper DC voltage, yeah, a reduced DC voltage that will be used for driving the relays, and also a small amount will be used to drive also the control board. Yeah, to obtain the proper voltage, that is 3.3 volts in our case. Yeah, because we have a 3.3 volt compatible logic here, and also we have the ESP8266 that is running on 3.3 volts. Yeah, we have here a proper designed switch mode power supply. Yeah, so it's not the standard classic linear power supply that is becoming insanely hot and you need to put a big heatsink on it. Yeah, it's not the 78 whatever. Yeah, it's a proper switch mode power supply. Yeah, that will supply our ESP8266 and our driver module. Yeah. Okay, so with all these things mentioned, because people were asking me to mention them, let's try to jump directly to the software side, and I will do it backwards. I will start the software, run the software, and after that we will go and see the code. Yeah. Okay. So let me plug in the board. Okay. As you can see here, the board is connected to the mains. Yeah, actually to directly to the main socket. Yeah. So we have the live and the neutral lines. Yeah. When the board is started, you have seen the blue LED blinking. That means that the board was booting okay. This LED, it's the power supply LED. That means that power is good. Yeah. So the power that is coming from the switch mode power supply is good. Yeah. And here on the top, you can see 8 LEDs. These 8 LEDs are giving you the status for the 8 channels that we have here. We will talk a little bit more later about these 8 LEDs and how it's working, this status panel, if you want. Yeah. Okay. Now I really want to jump directly to the software side. So as you can see here in the browser, after the ESP8266 has booted properly, has obtained the proper IP address from our DHCP server and is connected through Wi-Fi. Yeah, and the interface that I designed for this board quick presentation. Let me put it like this. Maybe you can see better the status LEDs. It's very simple. The interface is very simple. It's a demo interface. So basically we have 8 buttons named X1 to X8 because here on the board each relay switch has an X name. Yeah, so this one, for example, it's X4. This one it's X5, and so on. Yeah. Okay, so let's see what's happening. If we press the X1 button, you see that the first LED is going off. X2, X3, X4, and after that X5, X6, X7, and X8. Yeah, and now all the LEDs from the panels are off. That means, and this is very, very important to understand, that means that the switches inside the relays are on. So means that these switches are closed. If I press the off button, the general off button, you see all the LEDs are coming on, and you have heard the relays, all the 8 relays has switched off. Now let's talk a little bit about the status panel, if you want. Why these 8 LEDs are wired in such a strange way backwards, if you want. It's very, very simple, and it's coming from the industrial panels, if you want. Yeah, on an industrial panel, because in the history they were using many years ago, even now in some panels they are using standard light bulbs. Yeah, you can have situations when the light bulb it's burning off. Yeah, so it's broken and it will become off. Yeah, if somebody want to work on that line, for example, yeah, and he will go first on the status panel to see what's the status of that light, of that line. If he see the line, the light off and is connected in that way, that means off, it's off, and light on means line is on. He will do the wrong assumption that the line is off. He will go there, try to work, touch the line, and probably will die. Yeah. So the solution was to use this kind of signaling, if you want. Yes. When light on, the light on here means this channel it's off, and when the light is off, you need to assume that this line is hot, this line is on. Yeah, of course, if the LED is broken and you will find the line it's off, it's okay for you, but it's no way to have a wrong signaling for a lifeline. I really hope that you understand how smart this very simple but very smart way to signal the status of the line is for you and for everybody. Yeah, so we just decided to use it uh, in this way, and it's also looking very nice. Yeah, when we are powering on the board, if all the channels are off, all the LEDs are on, if you have a very nice uh, mm, glass, a panel glass, maybe diffused a bit, it's looking very nice. Yeah, so this is how it's working. Again, now everything is off. Yeah, you see I'm pressing the off button, everything is off. I'm activating line 1. Yeah, you see LED it's off, that means line is on. And now if I want to turn it off, I press again, and now I know for sure that the line is off, and working on that side it's safe. Okay, now let's see the software behind. I must tell you that I start using also ESP Basic in the latest month or so, maybe 2 months, and I find it very good, especially for simple things and also for beginners to start to learn programming. I know there will be people saying that no, you know, these days it's you just need to learn properly C++ or ASP or Java or whatever. But I really think it's a very good start. And sometime when you want to do very quick, I don't know, test rig or something like that, you don't want to stay in the code for days because it really doesn't make sense. Yeah. Same thing with this switchboard relay. Yeah. So you have 8 relays, you want to have a proper status, and you want a simple program, and you want a simple web interface, and that's it. Yeah. It's very simple. And of course, nobody is stopping you to just use the programming header and code in SDK or C++ or Arduino IDE or Lua or whatever. Yeah. Okay. Okay. Now back to our software. The software is deadly simple. Actually, what's happening, as you can see here from the first line, you understand that the driver that we are using for our relay board, it's based on the PCF8574. Yeah, so basically it's a PCF 8574 that it's 8-bit GPIO extender. Yeah, that is connected directly to the next bus. Maybe if you look back, you can see the simple example that we have with the driver for the PCF 8574. Yeah, so the PCF 8574 is connected on the next bus. So basically we are using only 2 pins to drive the I2C bus. The selected address for this board now it's 56, but as you remember, on the back of the board we have 3 jumpers, so we can change also the address. and because we can change the I2C address of the driver using the next bus, we can stack boards. Yeah, so imagine this board being the main board. Yeah, this is the main board, and this one will be with the ESP8266 on it, and after that you can have another board without the ESP8266, just connected through the next bus, and after that you can have another board, and you can also connecting it through the next bus. Yeah, so you can just stack them together. Changing the I2C address will let you to basically connect like eight boards. Yeah, so basically that means 64 relay lines or something like that. Yeah, okay, so because we are using this IC, yeah, as a GPIO extension, the driver it's almost similar with the one that we have written before, so I will not insist too much. What I want to tell you, and this is something new, in the latest version of ESP Basic, in the latest release, we have finally the new I2C setup function. It was not available on the previous versions. Basically, this function will let us to define and choose our own GPIO pins as SDA and SCL. Yeah. So from the standard 02, as it was in the previous version of ESP Basic, now you have the I2C setup function that will let you to define your SDA and SCL pins. In our case, it's 4 or 5, 4 and 5. Yeah. After that, everything is similar with the previous software driver example. You can go back and take a deeper look there. Yeah. So basically, we are just starting the I2C bus, and we are writing the corresponding values for each of the lines that we want to drive. Yeah, we are doing a little bit of bit masking to obtain this independent switching between the lines. Of course, if you don't want independent switching and you want to do it as a mutual exclusive 8 line switch, you can use the other driver that you will find in the previous examples done with the PCF 8574. Yeah, so what can I say? I really think this is probably the simplest way to end up with a web interface from where you can very easy command in real time your your switchboard, and I really think that this one can be a very powerful tool also for uh, future software development and even hardware, because you can have the ESP8266 on the board and with the full header access and with the reset button and with the interface for programming. You can do a lot of things. Yeah. Of course, and this was another question. Yeah. Of course, uh, nobody's stopping you to just take the module without the ESP8266 module. Yeah. So just board, if you have the board only without the ESP8266 module, through the next bus connector, you can connect it to your own Arduino board, to your own STM32 board, your ARM processor board or whatever board are you using there. uh, Even your Raspberry Pi, why not? Yes, you can use it also with your Raspberry Pi or BeagleBone Black, or I don't know. I really don't know. There are already zillions of boards around. The only thing that you need to keep in mind is that the next bus, it's an I2C bus, so it need to be I2C compatible, and it need to be 3.3 volt logic level uh, compatible. Yeah. Okay, so that's all for today. I really hope you enjoy it, and of course, if you like it, please subscribe to my channel, and also please give me a big thumbs up. Thank you very much.